Considering example 1, say we want to find the voltage measured by our voltmeter using mesh current analysis. In our circuit below, we have an independent voltage source applying a potential to a 32 ohm resistor. This 32 ohm resistor is connected to another 32 ohm resistor as well as a short circuit in which IA travels down. Our second 32 ohm resistor is connected to a current controlled current source where the output is proportional to our short circuit current. To begin, we'll apply our standard 4-step procedure. Our first step is to construct n meshes, where we have mesh 1 and mesh 2. Mesh 1 spans our 24 volt source and our 32 ohm resistor, as well as our short circuit, whereas mesh 2 spans our short circuit, our other 32 ohm resistor, and our CCCS. Step 2 is to apply our voltage potentials consistent with the passive sign convention and not to duly label any shared elements. Thus, we have V1 and V2 prescribed across our two 32 ohm resistors, and we do not need to apply a voltage potential across our CCCS. Rather, we are going to be interested in the voltage measured by our voltmeter. Step 3 is to construct n minus n sub c KVL equations describing each mesh current. We will apply our KVL equation to mesh 1, for mesh 2 is known by inspection. That is, 5IA is equal to minus I2. In doing such, applying our KVL equation to mesh 1, we have minus 24 volts plus V1 is equal to 0. Step 4 is to apply Ohm's Law to express our voltage potentials in terms of our mesh currents and resistances. That is, for mesh 1, we can say minus 24 volts plus I1 times 32 ohms is equal to 0, which gives I1 equaling 0.75 amps. Now we still have to determine our voltage measured by our voltmeter. To do such, we recognize that our short circuit IA is shared by mesh currents I1 and I2, such that IA is equal to I1 less I2. And we know I2 is equal to minus 5IA. Given that we have I1 is equal to 3/4 of an amp, we can solve for I2 such that I2 is equal to 1.25 I1 or 0.9375 amps. Now we can apply KVL to our second loop to determine our voltage measured by our voltmeter. That is, V2 minus Vm is equal to 0, where minus Vm comes about from the negative terminal being connected to the right-hand side of our 32 ohm resistor and our red terminal being connected to the bottom of our CCCS. Therefore, Vm would be equal to I2 times 32 ohms or 30 volts.